All right, so let's go over the gas laws. There's 4 we went over. Boyle's law was the first one. So what was Boyle's law? Boyle's law.
Like the equation thing?
Yeah.
V1 equals P2, V2.
Right. And so this just relates pressure to volume. Volume expands, pressure goes down, volume gets compressed, and pressure goes up. There's Charles' law. What's this one say?
V1 over T1 equals V2 over T2.
Right. And this one just tells us that if we raise the temperature, volume gets bigger. If we lower the temperature, volume gets smaller. That's kind of something you probably already knew. You heat something up, it gets bigger. You cool it down, it gets smaller. It does happen to a smaller degree with solids, but with gases, it happens this way. Oh, how rude. All right, let's see what they want. C225.
Why do you have to say that? They know
All right.
C225.
Going home.
Oh, your mom got B2.
All right, number 3. This one, I don't know if I gave you the name. This is
Yeah, you
pronounced.
did.
Okay,
Yeah.
good.
You said we were going to make fun of it.
Yes, it's Guy. We're not going to make fun of it. Guy Lusek. This one is P1 over T1 equals P2 over T2. Okay, so there's the 3 basic gas laws. And then we know if we combine all of them together, we get the combined gas law. And the combined gas law, of course, just puts pressure, volume, and temperature all into one law. And this just tells us anything that these 3 told us, right? So if ever we have a situation where one of these variables doesn't change, we can cancel it out, and we get one of these simpler ones. Okay, so that's everything we talked about so far. So now we're to the last gas law, and the reason they came up with this one, which is going to be called the ideal gas law, is that for all of these, to figure out anything we're looking for, we have to know the conditions at some earlier point in time. In other words, if I want to use Boyle's law, and I want to know what the pressure is now, I need to know what the pressure and the volume were before. Or if I want to use Charles' law, and I want to find out what the volume is now, I need to know what the volume was and the temperature was at some other time. So all these have that. They all have these little 1s and 2s indicating different periods in time. So now we've said, well, can we come up with a law where we can just look at what things are doing right now and figure out pressure, volume, temperature? And there's one more variable we need so we can do that, and that's the number of particles, the number of atoms or molecules inside that substance. And so that's what this equation is going to give us. So this is called ideal, starts with I, ideal gas. And so this one is PV, notice there's no 1s or 2s, equals nRT. And I'll give you these what they are, but go ahead and circle it, put some stars around it. Little fireworks. This is the granddaddy of all gas laws. This is the number 1. It has everything in it. Yes. You have to write granddaddy of all gas laws. Yes, write that. So that's it. This is the one. This is what we've been building up to here. This is the number 1 gas law.
Please pardon the interruption. Ms. Chinichi, please call extension 2512.
Okay, so let's go through now. I'm going to tell you what all these things are. Some of them you know what they are. P, of course, is pressure. V is volume. And then N, you haven't seen N before. N is the number of particles. Oh, sorry, don't write that. Write number of moles, excuse me. And so what a mole is it's a way for us to figure out how many particles there are. So if I know how many moles of a substance I have, then I know how many atoms or how many molecules there are, depending on whether it's made up of atoms or molecules. So this tells me how many there are. So you can just write in parentheses, because I'm not going to spend a whole lot of time on moles. Just write a mole is a given number of atoms or molecules, or ions, whatever. We just write particles if you want. I'm not going to tell you what the number is, because it's a big number. For some reason, really big numbers confuse students sometimes. So I'm not going to give you the number right now. Just know it's a number, right? It's like a dozen is 12 and a score is 20. Well, a mole is a certain number of particles. We'll talk about a mole later in the year. R is just a constant. Because whenever we do this, we're going to do it with all different kinds of units, and we need some constant to fix all our numbers and make everything come out right. For our purposes, and there's a million different versions of R, the one we're going to use is 0.0821 liters times atmospheres. Again, just write the units down, don't think about them. Moles times Kelvin. And if you look at our equation, it's got four things in it. It's got volume, pressure, moles, and Kelvin, and temperature. So we need these units to cancel out and make our answer come out with the right units. So that's why they got to be there. If I gave you pressure in kPa, if I gave you temperature in something else, we would have a different R. If you Google R for gas laws, you're going to find like 50 different ones on Wikipedia. Get a long list. You've got to find the ones that has the units for all the stuff that you're using. We're going to use this one. Temperature, T is temperature, right? Okay, so there we go. So the important thing about this gas law is now that we've incorporated number of moles, or essentially number of atoms, now we can figure out everything we need to know without needing to know the conditions at some previous point in time, without needing all these 1 and 2 subscripts. All right, let's go ahead and do a problem. Okay. Right there is fine. Let's say example 1. No, I don't have a problem here. Hold on. Let's do if a container has 62 moles of a gas. And don't forget, these things only work for gases, right? Solids and liquids don't change volume. 62 moles of a gas at 625 Kelvin. Promised myself I'd write meter, but I'm failing miserably. 625 Kelvin. And the volume is, I'm going to pick a number.
68.
68 liters. Everything's sixes here, huh? What is the pressure? All right, so you guys know what to do. We're going to start listing our givens, right? We're going to look over the equation. We should have, hopefully, some of those things, right? Preferably 4 of them, and one we'll be looking for. What's pressure? You don't know it. That's the question mark. What's volume?
68.
68 liters. N?
Is 62.
Yeah, exactly. N's always going to be the one that has moles in it. So you get used to looking for moles when you're looking for the one that's going to be the N. 62 moles. R?
0.082.
Exactly. I didn't give it to you, right? But this is a constant, so it's always going to be this number, unless we use different units. Liters times atmospheres over moles times Kelvin. And then temperature? 625, right? There we go. Okay, so pressure is what we're looking for. So write the equation down. PV equals nRT. How do I solve for P? I go sides by P. That's it. B, B. These cancel. Pressure equals nRT over volume. Now all you gotta do is plug in numbers. So it's going to be 62 moles times 0.0821, and a bunch of units. Okay, times temperature, which is 625 Kelvin. What's up?
I was right along that line.
Oh, I'm sorry. Divided by volume, 68 liters. All right. Let's cancel all the units. Kelvin goes away, moles goes away, liters goes away. So our answer is going to be in atmospheres, which we expected because we're looking for pressure. All right, go ahead, plug in numbers. Here, Haley, I'll write what you don't know.
I just need R and T.
T is temperature. R is 0.021. Yeah, always for these units. All right, so what do you get here?
46.78.
46.8? Sounds good. And that is going to be atmospheres. There you go. I feel like at this point you guys can read the problems, you can list your givens. If I gave you a problem where I needed you to solve for, say, temperature, for example, right? Let's say I did that. So we have a problem, we gotta solve for temperature, what are you gonna do here?
Divide.
Divide both sides by NR, yeah. So it'd be PV over NR equals T. So I trust you guys can solve this equation for any of the variables. Obviously, we're not going to solve for R because that's a constant, right? Questions?
Nope.
You good?
Yep.
All right, let's do it.
Hot worksheet.
I made this one kind excuse me.
Excuse me.
I made this one a little long, so what I want you to do is just do the first 5, and then do the periodic table on the back, of
Do
course.
you want me to stop the video?
Yeah, somebody. Please do
Hey, you
that.
got it? You got it?
We just did 1 through 5 and that's it.
1 through 5, and the periodic table on the back. That's it.
Yeah. I thought the second one.
Feeling nice today.
The second one was better than my shit.
Oh, it's real.